interesting thing about the world around us is that it's very multidisciplinary.
I think the biggest thing that gets me going is knowing that what I'm studying or what I'm researching will have an application, a direct application, to improve human lives.
You need to be doing something great all along the way. And when you're at the university, yes, it's about learning, but be applying that.
And in the college here, we have people working on solving many of the important problems that we face these days, from the environment to energy to almost anything that we worry about. It's engineers who are working on solutions to these problems.
The College of Engineering has faculty that are very interested in cutting-edge research, but also very interested in teaching. And so the kind of mentoring that they do is very unusual.
And that's what's happened. It's what happened here. You set up an environment and unexpected things happen.
The professors here are really wonderful at being approachable, about caring about their students, and answering any questions they might have and helping them out whenever they can.
My research is in simulations of combustion processes. So we use very large computers to simulate combustion events, big fires, furnaces, boilers, to make power, to see combustion affects the world in so many different areas.
My research and the work that goes on in this lab are really in two different but related areas. One is solid-state liquid chemical sensors. The other area in which we're doing work is low-power microcontrollers.
I teach biophysics and biomechanics and other areas in bioengineering here at the University of Utah. And those topics cover basically biomedical devices, how they work and how they interface with the body. My own area is in hearing and balance.
My area of research is medical instrumentation, and my particular focus at the moment is putting sensors in shoes to look at how people are walking. As I went through high school, I really loved physics, and I thought I was going to go to college and become a physicist. As I got through the freshman year of physics, I found what I really liked at that time was the mechanics part of physics, and I thought, well, I'll go be a mechanical engineer.
When I worked at Hewlett-Packard, I was working on light-emitting diodes, but I had an idea for a new kind of a light-emitting diode made in a new way. And so I came here and started working on the materials that are now used in traffic semaphores.
I direct the Scientific Computing and Imaging Institute at the University of Utah, the so-called SCI Institute. The types of research that we do here within the SCI Institute involve, I think, the pillars of scientific visualization, which we're best known for. On the educational side, I think some of the most exciting moments that I have, and these happen all the time, is when I have students that come in and say that are excited themselves. They've been working on a problem for a long time and they've had a breakthrough, and they want to immediately take me to their computer and show me what they've done.
When I was a little boy, I dreamed of being a farmer. That was as far as my horizon could reach. The University of Utah was very far away from me at that time, and it was coming here that that horizon was extended beyond anything I could ever imagine.
When I was young, I think I changed my mind every other week in terms of, wanting to be a fireman one day, a stunt person the next day, a pro basketball player the next day, etc. And I've never been able to just do one thing. So I think that I like to do so many different things. I'm so interested in so many pieces of the different sciences and engineering and mathematics and medicine.
I actually wasn't interested in engineering to begin with. I was interested in computer science, and when I went out and worked and got to a place where I knew I wasn't going to advance anymore, I decided to go back to school and took some engineering classes and was really interested in it, and I was hooked from there.
I started here in 1963 and originally came into physics. And I was in physics, in fact, I got my degree in physics, but in the last year and a half, there was this new field of computer science. So I started taking computer science classes, so I ended up getting 2 degrees, one in computer science and one in physics. You know, originally when I was in high school, I wanted to be an animator. I didn't go into animation because I believed at the time I couldn't draw well enough.
I discovered a subfield of material science, ceramics. Well, at that time, in the 60s, we had, of course, Sputnik earlier, and we had a feeling in the United States that technology could solve a lot of problems, and so I wanted to be part of that discovery process.
So when I was little, my dream was to become a pro skateboarder, but now it's changed to becoming the best surgeon or physician that I possibly can. And so the tools that I used during my engineering degree actually, to my surprise, are going to help me a lot more in medical school than I thought.
Throughout high school, I started to realize that I liked math and science, and I took calculus and chemistry and physics, but I didn't really know what I was supposed to do with it. I want to be a design engineer, and I think that's so cool, that you can build something, have it fabricated, and get it back, and like, I made this. It's pretty cool.
This university, I think, is unique in that the undergraduates and the graduate students are interested not only in the experience they have while they're here, but what is the end product.
The great thing about the University of Utah here was being able to sit in on so many different classes and different departments within the College of Engineering and outside of it. And those different things are part of what catches fire later.
You know, coming on campus, I didn't realize how many things were responsible from engineers, you know, video games and your electronics and so forth. You know, but what about my Gore-Tex jacket that I wear when I go skiing, or the rubber shoes that I'm wearing right now?
When I came back to graduate school, I could see that here was an opportunity to mix art with computer science. So that class just rearranged my life. As a graduate student, I was in this remarkable program here.
My dream is to, in 20 years, I want to be finished with my schooling. That's a good goal. But I'd like to be a professional. I'd like to be someone who's making a difference in the world.
I dream to go out and explore not only the technological world, but also the business world.
The things that you can discover here at the University of Utah doing engineering are vast.
It's the discovery of seeing all of these fundamentals come together in one system that excites students.
You get to know everyone in your classes, and you all become friends and study buddies, and there's just a lot of camaraderie.
In the College of Engineering, that one of the best things that we give them are better problem-solving skills.
I discovered how much self-discipline I can have. I didn't know how much discipline I was actually capable of, and I was happy to see that I could set goals for myself and actually follow through and achieve them.
But what I really like about the mechanical engineering program is the amount of hands-on that students get in our program.
There are personal things for me to discover. There's certain things about history, about the way people work, about the way organizations work that I'm trying to understand.
We have no idea what will come next, but it will be because of discovery.
I think I was very fortunate to come to the college at the time I did, when I could build on top of the foundation that these other wonderful deans had already laid.
When you graduate, learning isn't over. It's about exploring, exploration, discovery, and continuing to learn.
The Warnock Building, I think that'll be a very, very integral place for students to bond and interact with each other.
For me, each student should really discover and explore in the environment that they're in, the things that are there or the potential that's there.
You can do all sorts of things, and I've just found that through the College of Engineering, you're trained to be successful in life.
When I've discovered something new, you know, when the light goes on and something you understand for the first time any person has understood some phenomenon, how to describe that in words. I don't think there's a way to describe it in words.
My entire experience here, it's certainly something I'll never forget.